I would like to introduce Laura Gusatu. She's a PhD candidate at the Planning Department of the Faculty of Spatial Sciences at the University of Groningen. She's our specialist in, okay, do we really have the space and what happens? So quite naturally, her presentation will be spatial potentials and environmental effects of offshore wind farm development in the North Sea Basin, and she may tell us, is this all possible, or do we have more restrictions and we can't have all the high-flying plants realized? Please, Laura.
Thank you very much for the presentation, and also thank you for the previous presentation. It was very, very interesting to hear more about from the perspective of from Mr. Lars. So as it was mentioned before, I would present the spatial potentials and environmental impacts of offshore wind farms. I will briefly go through the current and future spatial constraints of the development of offshore wind farms, the future opportunities, but also the environmental impacts of the large-scale deployment. And last, I will present, I would say, a few words about the impact or the insertion of spatial and non-spatial components in the energy models. As it was mentioned before, the North Sea is perceived as a very attractive basin for deploying large-scale wind farms due to the very reliable wind resource, the relatively shallow waters, especially in the south, but also the proximity to the energy markets. However, this is not completely true because the offshore space is divided between a multitude of activities, and we can just to count for a number of them. We have military activities, we have a large network of protected areas for different marine species, we have oil and gas infrastructure, cables and pipelines, we have the traditional fishing activity, shipping, and in this mix we need to also include the large-scale deployment of offshore wind farms. How will this be realized in a sustainable manner while also safeguarding the marine environment? Traditionally, these activities have been managed in a sectoral manner from international and national legislation such as UNCLOS, OSPAR legislation, or more nationally the Mining Act, just to give a few examples. However, recently through the Marine Strategy Directive, the North Sea countries will need to provide marine spatial plans that account for all these activities in an integrated manner. However, this is not a straightforward process, and just to give an impression of which are those spatial claims in the North Sea, we have compiled a repository of offshore activities and their footprint in the North Sea area, and you can see here the North Sea Basin surrounded by North Sea countries, also divided by the exclusive economic zones through the red lines. And we have oil and gas installations, pipelines, shipping lines, military areas. This, however, only gives just a brief grasp of what are those activities in the present, because there are also future claims to be considered. There are more offshore, more shipping lines that will be taken into account, linking the southern part of the North Sea, for example, the Dutch ports, to the northern part of the North Sea. We also have the depletion of oil and gas resources, which would lead to decommissioning of oil and gas infrastructure in the Dutch and the Danish EEZ, but we also have new fields being discovered in the Scottish part. We have cables, Natura 2000 areas, waste disposal and fishing activities, but we also need to take into account the future, the increased concerns on marine environment, and therefore the commitment of national governments to provide more space for Natura 2000 areas, and you have circled in the second map locations of these areas. In order to account for all these claims and to calculate the availability of space for offshore wind farms, In the future, we have compiled and developed and visualized a number of 4 scenarios, taking into account 2 main drivers, namely the national interpretation of energy targets, of EU energy targets at the national level, but also the type of planning of offshore activities. So we have either sectoral planning, which takes into account the interest of individual sectors, but we can also have integrated planning, which takes into account in a balancing manner all claims offshore and is promoting a participatory process. So those are the main drivers, but we also have secondary drivers, which implies taking into account the dynamic offshore space, so therefore the future claims for more protected areas, the decommissioning of oil and gas platforms, but also more shipping lanes or a higher intensity of shipping activity. We also took into account 2 techno-economic drivers related to the cost of offshore wind farms. So we divided the space by distance to shore and water depth, as distance to shore is related to the type of foundation, either fixed bottom or floating. And the water depth is related to the cost of the system, so cost of installation, operational maintenance, but also extension of the grid. And you can see on the right side of the slide the visualization of the 4 scenarios, going from scenario A, which is a scenario with high targets and integrated planning. That means we take into account the possibility to have more claims offshore from other activities, but we also take into account the possibility to combine activities through multi-use of space. And we also have scenario C, which is the opposite, having sectoral planning, but also low targets. That means the energy deployment will not be prioritized, and we will have even more claims offshore. And as we can see in all scenarios, we have a low availability of space in the southern part of the North Sea, marked by the white beige areas. And also a higher availability the further we go from the shore, so in areas with the water depth below -55, and that emphasizes the need to deploy floating offshore wind farms. When we're looking at areas that are under 100 kilometers from shore and above -120 meters, we can see a big impact played by the multi-use of space. So in scenarios A and B, we can have an extra 20 or 30 gigawatts only when considering multi-use of space on top of single use. And that brings us to the multi-use of space concept, which is one of the key elements seen in tackling the scarcity of space offshore. And one of the most controversial multi-use of space options is the combination with fisheries. In our scenarios, we can see that this takes place mainly over 100 kilometers from shore and can bring consistent additional gigawatts. We can also have multi-use with marine protected areas or with a natural environment. Also taking place over 100 kilometers from shore. Therefore, in meeting the EU targets in an integrated manner, we can consider multi-use with fisheries or with protected areas. We, however, need to take into account the different trade-offs. And to name a few, we have the design adaptation of offshore wind farms to accommodate these activities. We need to take into account the data, knowledge exchange between those sectors at an early stage in the planning process. We also need to understand the social-cultural impacts of fisheries displacement, for example. And we need to have in place financial instruments for future research in better understanding the impacts that can occur in those interactions. And last but not least, we need to have monitoring programs to better understand the risks and effects on the marine environment. And that leads me to the second part of the presentation, which is the environmental impacts of offshore wind farms. And we can see that with the large-scale deployment of offshore wind farms, and you have them plotted in the map on the right side of the screen, there are increased concerns related to the cumulative pressures on the already notably impacted marine ecosystem. And we know that offshore wind farms, in the authorization process, they need to go through the environmental impact assessment that takes into account the pressures on the environmental components. However, currently there are a number of gaps that can be classified in spatial gaps and temporal gaps. And just briefly, the spatial gaps are related to the mismatch between the scales at which the impacts are assessed and the scale at which ecosystems function. So we know that anthropogenic pressures have transboundaries pressures, so they're not limited on local space. We also have temporal gaps because we need to take into account the different timescales of offshore wind farm pressures, but also we need to monitor those pressures on the long term. In order to account for these environmental impacts, we used a geospatial model called Tools for MSP, developed by Stefano Menegon and Daniel de Pellegrin. This model is taking into account the spatial distribution of pressures, the sensitivities of different environmental components, and calculates, therefore, the impact of different activities, in our case, offshore wind farms. We compiled a repository of offshore wind farms on a temporal scale. Therefore, we are taking into account the construction phase, so the duration of the construction phase, operation phase, and decommissioning phase. And we selected relevant environmental components from seabed habitats to mammals, seabirds, and fish. And you can see on this slide the area occupied by offshore wind farm phases. So we have a peak around 2023 of construction phase related activities, and then a decrease of construction and increase of operation phase activities. However, I need to mention that we took into account the existing and existing and operational offshore wind farms. Therefore, there will be even more impacts to be accounted for after 2027, which is the last year that we have in our analysis. We also made the difference between the countries. So we see UK as having the highest impact, and we also made differences in results between the different phases, and we see the peak in impacts in the construction phase from 2022 to 2026, followed by the plateau of impacts. When looking at the spatial distribution of impacts, we also see different hotspots of impacts. And looking overall for the entire analyzed timeline, we can see areas of high impact, concentrated high impacts, and areas of dispersed impacts in Germany and in UK. And these results can support the decision-making process and can formulate alternatives, options for the location of offshore wind farms in the North Sea space. And to end with, this spatial data can represent an important input in energy models by offering a more realistic representation of the constraints and opportunities offshore. It can show potentials of different renewable technologies, and it can offer an input into the clustering and aggregation of data. Thank you very much.
Thank you very much, Laura. Thank you for a very interesting presentation. And we see we don't have all that much space in the North Sea, and it will take some good planning, and it will have impact.